So today we have related rates. All right, so this is going to involve, again, implicit differentiation. But this time we are going to implicitly derive X and we're going to implicitly derive Y with respect to time, d over dt. So for example, a seasonal product such as winter coats, the price Y and weekly sales X will be related by a demand equation, and both price Y and quantity X will depend on time. So with related rates, we're going to have the derivative of X and Y with respect to time, and those will all depend. I mean, not depend, but we will find the rate of those values depending on the problem. Okay. Steps to solving a related rates problem. Determine the quantities that are changing with time. Find an equation that relates these quantities. Differentiate both sides of this equation implicitly with respect to time. Substitute into the new equation any given values for variables and derivatives, and solve for the remaining derivative and interpret as a rate of change. So with related rates problem, to make all those steps simple, do not plug anything in yet until we take the derivative. Okay. So now we have our notations just like last time, but this time we are deriving with respect to time. We are implicitly deriving with respect to time. Okay, so this means that d over dt of x will be now x prime. And then d over dt of x squared will be 2x x prime, and then so on and so forth. So also the notation, well, here it is. Just know that if you see this on MyMathLab, dx over dt, it now means x prime. And then if you see dy over dt, this now means y prime, which we have our table here. Derivative of y with respect to time, y prime, derivative of y squared with respect to time, 2y prime, so on and so forth. So again, to keep the notation simple, we're just going to deal with x prime and y prime. All right.
Question.
What's up?
Could you put the worksheet in the chat, please?
Oh, sorry. Forgot to do that.
Thank
you. Mm-hmm. Let's see. And there we go. Okay. There you go. All right, and then another notation you might see, if it says find dp over dt, that is just going to be p prime. So whatever variables they give you. Okay, so let's go ahead and try these implicit derivatives with respect to time. So for number one, let y equal x cubed minus 3 and x prime equal -2. When x is 2, find y prime when x is equal to 2. So we're going to take the implicit derivative, and then we're going to plug in the components that it's giving us. Okay. Oh yeah, I'll leave that screen there, and then, okay, cool. So for number one, we're going to say d over dt of y is equal to d over dt of x cubed minus 3. And then d over dt of y is going to be y prime, and d over dt of x cubed, which is now going to be an implicit derivative of x, is going to be 3x squared x prime. And there's our implicit derivative. Okay, so there's the implicit derivative. The next thing we have to do is evaluate it, given that x prime is -2 and x is 2. Okay. So now we're just going to say y prime is equal to 3 times, and then when x is 2, you'll plug in 2 and square it, and then x prime will have -2. I guess I could have wrote that other notation here. Hang on, let me change this up real fast. I'll say this. We're going to say evaluate y prime when x is 2 and x prime is -2. There we go. So now you'll get 3 times 2 squared times -2. And y prime, that's going to be 3 times 4, 12. We're going to get -24. Okay, there we go. Any questions on that? So now we're taking the implicit derivative of everything with respect to time. So we're going to have y primes and x primes now.
So when you use the x prime,
Mhm.
you substitute for the -2, you'll put it in where the actual x prime,
Exactly.
and then the 3x squared is just a regular.
Exactly. So that 2 will go in for that x, and that -2 will go in for that x prime.
Okay.
Okay. Let's try it again. Evaluate x prime for x squared minus 2xy minus y squared equal to 25 with the conditions y prime is -1, x is 2, and y is -1. So again, we want to take the implicit derivative of this equation. So we're going to say d over dt of x squared minus 2xy minus y squared equal to d over dt of 25. Okay. So this one, we're going to have a little bit of work to do. So before we move on, this x times y is now going to need an implicit product rule. So this is going to be an implicit product rule. And I'll say of x times y. Okay, so like before, f will be x and g will be y. And now we are taking the implicit derivatives of both of these functions with respect to time. So this means that f prime will be x prime and g prime will be y prime. Okay, and then let's go ahead and continue our derivative from the original equation. And the implicit derivative of x squared is going to be 2x x prime minus 2 times the implicit product rule derivative of x times y, which is going to be x prime y plus y prime x. But I'm just going to write that as x, y prime, just because it looks neater. Okay, and then before going a step further, we're going to have a formula, a new formula now. So the implicit product rule of x, y is now going to be x prime y plus x, y prime. So save that somewhere to save you some time. Now let's continue this derivative. Now we want the implicit derivative of negative y squared, which is going to be -2y y prime all equal to 0. Okay. And our goal here is to evaluate x prime. So that means we're going to solve this whole equation for x prime. So let's go ahead and do that. All right, just going to rewrite this. 2x x prime, distribute that -2, -2, x prime y minus 2xy prime minus 2y prime equal to 0. Now we're solving for x prime, so I'm going to move everything over that doesn't have an x prime. So that means that this term and this term, they're both moving to the right side. So we're going to get 2x x prime minus 2x prime y equal to 2x y prime plus 2y y prime. And now to solve for x prime, well, actually, before we do any of that, we can actually divide everything by 2. That'll help us reduce it. So I can say divide by 2, divide by 2, divide by 2, divide by 2. And then let's go ahead and move this up here. Which means you'll have x prime minus x prime y equal to xy prime plus yy prime. Okay, so all I did was divide everything by 2, take some work off of us, and now we're solving for x prime. So I have an x prime here and an x prime there. So I'm going to factor out an x prime, which would leave me with x minus y equal to xy prime plus yy prime. And then just to solve for x prime, we're going to divide by x minus y. And we get x prime is equal to x y prime plus yy prime over x minus y. And there's our implicit derivative with respect to time that we have just solved for x prime. And now we have to plug numbers in, but I'll let you soak that in and ask any questions.
So why do we divide by x negative y?
So x minus y, because we're solving for x prime. So we have to get x prime by itself. Because if we're solving for x prime, on this step, I factored out an x prime.
Okay, I see that now. So you're just factoring out and then you divide by it to get rid of the parentheses?
Exactly, because now you need to isolate x prime. So you divide by x minus y, move it to the right side, and all we get is this lonely x prime on the left.
Okay.
All right. Yes, I know it's a lot of letters and primes to look at.
So how do we always have to solve for x prime, or do we have to do
It's
the
gonna
whole
tell
thing?
you solve for x prime or solve for y prime.
Okay.
The last problem was find y prime,
Okay.
which that was a really easy one.
Thank you.
This one is evaluate for x prime, which means solve for x prime and then evaluate it with the given conditions above. So we still have to plug in those numbers above.
Thank you.
So now we're going to say evaluate x prime when y prime equals, actually I'll say when x is 2, when y is -1, and y prime equals -1 as well. Okay, and let's plug in to our function. to our derivative, and you're going to have 2 times -1 plus -1 times -1 over 2 minus -1. And that's going to give me -2 plus 1 over, that becomes plus 3. So we're going to end up with -1/3. And there it is. -1/3 is the value of x prime. And just a quick little side note, if we were talking for an ML, my MATLAB answer that uses all the dx and dt's that I don't like to use, then this is what format it would like. It would say x prime, actually, it would start with dx over dt equal to x times dy over dt plus y times dy over dt over x minus y. So that's a possible way to input it if my MATLAB wants it like that, which I think just looks a lot messier. But just know the difference between the notations. Okay, any questions on that one before moving on? Lots of letters, lots of primes, so very easy to make a mistake. Okay. All right, 2. Suppose that for a company manufacturing calculators, the costs, revenue, and profit equations are given by cost is 72,000 plus 60x, revenue is 200x minus x squared over 30, and profit is always revenue minus cost. Okay, where the production output in 1 week is X amount of calculators, if production is increasing at a rate of 500 calculators per week at a production level of 1,500 calculators, find the rate of increase or decrease in cost, revenue, and profit. Okay, so before we even start messing with the equations, we have to put labels on what the problem's giving us. So here we know that X represents the number of calculators. So we're going to say that X is the number of calculators. Okay, and then the next line says if production is increasing at a rate of 500 calculators per week, what notation would you put for rate? If X is the number of calculators, and then we have that the number of calculators are increasing at a rate, well, what special word covers rate?
Time.
Well, you would take the derivative with respect to time, but rate just means derivative. And what is the implicit derivative of X with respect to time? Or did you say time or did you say prime?
I'm going to walk it back and say prime.
Okay. And prime, X prime would represent the rate of calculators. So whenever you see the word rate, that just means derivative. Okay. So here, the number of calculators, the regular number of calculators is going to be at a production level of 1,500. So X is going to be 1,500. But then the rate of how our calculator projection is increasing is going to be at 500. So we have to know how to pull the information from this problem. X is the number of calculators. X prime is the rate that we produce calculators at. And we are producing 1,500 calculators at a rate of 500 calculators per week. Okay, which means now we have our labels, which means we can now move on to finding the derivatives of the cost, revenue, and profit function. So for A, that's where we're going to start. I'll keep that right there. So we're going to say d over dt of C is equal to d over dt of 72,000 plus 60x. Now the derivative of C with respect to time is, guess what? C prime. And the derivative of 72,000 is 0. And the derivative of 60x with respect to time is 60x prime. There's the derivative for the cost function. Now let's go ahead and plug in the value of x prime. So we'll say C prime. I'll say C prime equal to 60 times 500. C prime equal to 60 times 500. And that's going to give me, is that 30,000? Yes. $30,000. So what this is telling us is that if we make 500 calculators per week, the cost is going to increase by $30,000. Okay, there's that. Now let's do the same for the revenue. So now we're going to say d over dt of R is equal to d over dt of 200x minus, and this x squared over 30, I'm going to rewrite it as 1 over 30 times x squared. They're the same exact thing. Okay. And now let's take the implicit derivative with respect to time. So this means we're just going to get R prime equal to the implicit derivative of 200x, which is 200x prime, minus 1 over 30 times the implicit derivative of x squared, which is 2x x prime. Now let's go ahead and reduce that. We're going to get R prime is equal to 200x prime, and 1 over 30 times 2 becomes negative 1 over 15 x prime. Okay. And there's our implicit derivative of the revenue function with respect to time. Okay. Now, let's go ahead and evaluate it by plugging in x and x prime. So we're going to say R prime is equal to 200 times x prime, which is 500, minus 1 over 15 times x, which is 1500, times x prime, which is 500. And if I do that, I'll get 200 times 500 minus 1 over 15 times 1500 times 500. And we're going to get $50,000. So what this means is that if we are producing 500 calculators per week, then our revenue will increase. Okay. And then the last one is easy money. It says, what is the profit? So remember, profit is given by revenue minus cost. Revenue minus cost. Well, we're going to take the implicit derivative of revenue. So we're going to say, not revenue, sorry, of profit. We're going to say d over dt of p equal to d over dt of r minus c. And this is going to give us p prime equal to r prime minus c prime. Well, this one's great because when you evaluate it, all we have to do is take the value we found in r prime and subtract it from the value we found in c prime. So this means that p prime is going to equal r prime, which was 50,000, minus c prime, which is 30,000, which means that we'll get a profit that increases by $20,000 per week. So what we're saying is that if we create 500 calculators per week, our profit is going to increase. Okay. That wasn't too bad. Any questions on that one?
That's 500 additional calculators on top of their 1500.
Exactly. So production is X calculators per week. So we're trying to produce 1,500 calculators per week, but we know that if production's increasing at a rate of 500 calculators, then we want to find out what the rate of increase or decrease was for these functions.
Cool, thank you.
Mm-hmm. Okay, well, let's keep moving. All right, 3. A retail store estimates that weekly sales S and weekly advertising cost X, both in dollars, are related by the equation S equals 50,000 minus 20,000 E to the negative 0.0004X. The current weekly advertising costs are $2,000, and these costs are increasing at the rate of $300 per week. Find the current rate of change of sales. Okay, so again, let's label everything we know before we begin. So here it's telling us that sales is S. So we'll just say, or actually, yeah. So S represents sales. I can't write. Sales. That means that S prime would represent the rate of change of sales. And then we know that X is the weekly advertising cost. So I'll just say advertising costs. And then X prime would be the rate of change of the cost. I'll say just rate of cost. Okay. Well, in the problem, it says the current weekly advertising costs are $2,000. So now we know that X is $2,000. And then it says these costs are increasing at the rate of $300. So that means X prime is going to be 300. And then we say, find the current rate of change of sales. So this means we are looking for S prime. Okay, which means all we have to do is take the derivative. Now these side notes are here for a reason, but I'll show you how to use them in a second. So we're going to say d over dt of S equal to d over dt of 50,000 minus 20,000 e to the negative 0.0004x. All right, one part's easy. D over dt of S is S prime. And then d over dt of 50,000 is 0. So we have a little bit of our work cut out for us for 20,000 e to the negative 0.04x. And that's where we are now going to have to take a chain rule, an implicit chain rule derivative, which is what we're going to use right there from the notes. What I'm showing you there is an implicit chain rule derivative. Okay. So I'm going to put 0 minus 20,000. I'm going to put a bracket to be neat. And what I just said was this part needs the implicit chain rule. So following this lovely formula here, d over dt of e to the x, well, it's going to be the implicit derivative of the exponent times the original function. So the implicit derivative of negative 0.004x with respect to time is going to be negative 0.0004x prime. And then all we have to do now is just multiply it by the original function that was there, negative 0.004x. And that's the implicit chain rule derivative. There we go. I'll make it prettier. Okay. And now just distribute that 20,000 and we're on our way. We'll put S prime equals whatever negative 20,000 times 0.004 is. So negative and negative is going to make positive. We know that. So 20,000 times 0.0004 is going to give me 8x prime e to the negative 0.004x. And there's our derivative. And now all we have to do is plug in x prime and x. So let's go ahead and do that. Okay. So we're going to say S prime is going to be 8 times 300 times E to the negative 0.004 times X, which is 2,000. And let me Desmos this really fast so I can show you how to type it in. Clear, 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 clear. Okay. It's 8 times 300. And then E, wherever you are, I'll just have to type it in. Whoops. On this keyboard, E raised to the negative 0.0004 times 2,000. There we go. And there's our answer. I get $1,078.39. Okay. So what this means is that since the output is positive, the rate of change of sales is increasing. So if we increase advertising cost, and if we're doing it the right way, then yes, our sales of a certain product are going to increase. So here we say sales increase. Okay. Any questions on that one? You're like, that was way too much. Okay. Next one. All right, example 4. Let me make that bigger. There we go. The price P in dollars and demand X for a product are related by X equals 7,000 minus 0.1 P squared. The current price of $100 is decreasing at a rate of $5 per week. Find the associated revenue function, R of P, and the rate of change in dollars per week of revenue. Okay. Let's see. Oh, because we're putting in terms of P. Okay. All right, so let's label what we know. The current price of 100, so P represents price. P is price, and they're giving us that that's 100. The current price of 100 is decreasing at a rate of $5 per week. So that means P prime would be the price rate or rate of price. And if it's decreasing, then that would be given by -5. Okay. And then X is the demand, but it's not giving us much after that. So X is demand. Okay. So it says find the associated revenue function, R of P, and the rate of change in dollars per week of revenue. So step A is find the revenue function. Well, if you remember, to find a revenue function, the formula is given as R of P is equal to X times P. And above, they have given us a formula for X, which means that is what we're going to plug in for this little X here. So this will become 7,000 minus 0.1 P squared times P. Go ahead and distribute that P, and you'll get 7,000 P minus 0.1 P cubed. And here is our revenue function. This is our revenue function, which means in B, since we found the revenue function, we're now going to take the implicit derivative of that function. So B, we're going to say d over dt of Rp equal to d over dt of 7,000 P minus 0.1 P cubed. The left side will become R prime of P. The right side will be 7,000 P prime minus, and the implicit derivative of 0.1 P cubed. That 3 is going to come and multiply the 0.1, which means I'll have 0.3 P squared P prime. Okay. And there's our derivative. And now C says find the rate of change of revenue in dollars per week, which means all we have to do is plug in P and P prime. So C R prime of P is going to equal 7,000 times P prime, which is -5, minus 0.3 times P, which is 100 squared, times P prime, which is -5. There we go. Go ahead and plug all of that in, and we'll get 7,000 times -5 minus 0.3 times 100 squared times -5, and we'll get -$20,000. Which means that by the problem, if the price is $100 and the price is decreasing at a rate of $5 per week, this makes sense that revenue would decrease. Okay. Whew. There's that one. We got one more. Perfect. All right. Any questions before moving on? It may seem like a lot, but it's not that bad. All right. Last one. 5. A company's profit from selling X units of an item is P equals 0.3x squared plus $8,000. If sales are growing at the rate of 20 per day, find how rapidly profit is growing in dollars per day when 600 units have been sold. Okay. So this means that X is the number of units. So X is the number of units, which means that X prime would be the rate of change of units. And I'll just say rate of units. Okay. So it says if sales are growing at the rate of 20 per day, this means that we're selling 20 units per day. So it's giving us another rate. So sales are growing at a rate of 20 per day. This means that X prime would be 20. And then it says, find how rapidly profit is growing in dollars per day when 600 units have been sold. So this would be 600. And of course, P is profit, and P prime is the profit rate or rate of change of profit. Okay. So all we have to do is take this function given and take the derivative of it implicitly. Okay. So we're going to say d over dt of P is equal to d over dt of 0.3x squared plus 8,000. We then know that the implicit derivative of P is P prime. And now the implicit derivative of 0.3x squared, that 2 will come down and multiply the 30 cents, which means you'll have 0.6x x prime. So, and the implicit derivative of 8,000 is still 0. So here's our implicit derivative. Okay. Now, all we have to do is plug in x and x prime. So P prime would be 0.6 times x, which is 600, times x prime, which is 20, and 0.6 times 600 times 20 would give me $7,200. Which means if we are selling 20 units per day, and if 600 units have been sold, and since this is a positive number, we know that profit increases. There it is. That is related rates. Any questions on that?